My dear students, welcome back to our channel. In this video, I will be explaining the MBA second semester subject Operation Research as prescribed by Osmania University, Palamuru University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: what is degeneracy in transportation problem? In a transportation problem, TP, degeneracy happens when the number of allocated cells, basic variables, is less than m plus n1, where m is equal to number of rows, sources, and n is equal to number of columns, destinations. Why it happens? Degeneracy usually occurs when supply and demand values are the same in more than one row or column. This causes fewer allocations than required to solve the problem properly. Why it's a problem? Degeneracy can block optimality testing, like in Modi or UV methods, and may give wrong solutions or cycles in the next steps. How to fix it? To handle this, we place a small value epsilon in an empty cell, which does not affect the total cost. This helps continue the solution steps. Example: if m is equal to 3, n is equal to 4, m plus n, 1 is equal to 6. But only 5 allocations are done. This is degeneracy. Easy tip: degeneracy is equal to missing one or more allocations in IBFS. Next important short question is: 2. What is unbalanced transportation problem? In a transportation problem, TP, when total supply is not equal to total demand, it is called an unbalanced transportation problem. Why it happens? In real life, sometimes a company may have more goods than demand or more demand than goods. So, the total supply and total demand are not equal. Why it's a problem? We can only solve the TP using methods like VAM or Modi when it is balanced. So, an unbalanced problem must be converted into a balanced one. How to solve it? If supply-demand, we add a dummy destination with the remaining demand. If demand-supply, we add a dummy source with the remaining supply. Cost for dummy cell is always 0. Example: supply is equal to 100 units, demand is equal to 80 units. Add dummy destination with 20 units demand and 0 cost. Easy tip: make unbalanced TP into balanced TP by adding a dummy row or column. Next important short question is: 3. What is traveling salesman problem, TSP? The traveling salesman problem, TSP, is a famous problem in operations research. It asks: if a salesman wants to visit a set of cities exactly once and return to the starting city, what is the shortest route he should take? This problem is all about finding the minimum cost or shortest distance to travel across multiple locations. Example: a salesman must visit 4 cities, A, B, C, and D. He starts from A, visits each city only once, and returns to A. We want to find the route like ABCD that gives the lowest total travel distance. Why it's important? TSP is used in logistics, delivery services, cab routing, Google Maps, etc. Easy to remember. Visit each city only once. Return to the starting city. Choose the route with minimum total cost distance. It's tricky but very useful in real-world planning. Next important short question is: 4. Mention differences between transportation problem, TP, and assignment problem, AP. Transportation problem, TP, and assignment problem, AP, are both allocation models in operations research. While they look similar, they are different in structure, size, and usage. Let's understand both first. Transportation problem, TP. TP is used when we want to transport goods from multiple sources, factories, to multiple destinations, warehouse, at minimum cost. Example. 3 factories need to supply products to 4 stores. Each factory has a supply limit and each store has a demand. The cost of transporting from each factory to each store is given. The goal is to minimize the total transportation cost. In short, multiple supply points, multiple demand points. Objective, minimize cost. Larger table, M times N. Assignment problem, AP. AP is used to assign tasks, like jobs, machines, workers, so that each resource is assigned to exactly one task, and the total cost or time is minimized or profit maximized. Example. 5 workers are to be assigned 5 jobs. Each worker takes different time to complete different jobs. The goal is to assign jobs in such a way that the total time is minimum. In short, one-to-one assignment. Objective, minimize cost or maximize profit. Always square table, N times N. Key differences at a glance. Feature transportation problem, TP, assignment problem, AP. Problem type many-to-many, one-to-one. Table size M times N, N times N. Objective, minimize transportation cost, minimize cost or maximize profit. Supply and demand varies, may not be equal, always equal, one supply per task. Example use case, shipping goods, assigning workers to jobs. Conclusion. Though TP and AP both belong to the same family of allocation problems, their structures, goals, and applications are quite different. Understanding these differences helps managers choose the right model for decision-making. Next unit 3. Long questions. First important long question is: explain Vogel's approximation method, VAM, with a suitable example. Vogel's approximation method, VAM, is a technique used to find the initial basic feasible solution, IBFS, for a transportation problem, TP. It gives a better starting solution compared to other methods like the northwest corner rule. Steps of VAM. 1. Calculate penalties for each row and column. Penalty is equal to difference between the smallest and next smallest cost in that row column. 2. Select the row or column with the highest penalty. This shows where making a bad decision would cost the most. 3. Allocate as much as possible in the lowest cost cell of that row column. 4. Adjust the supply and demand, then strike out the row or column where supply or demand becomes 0. 5. Repeat the steps until all supplies and demands are satisfied. Example. Let's say we have a transportation table. D1 D2 D3 supply. S1 19 30 57. S2 70 30 49. S3 48 70 18. Demand 5 8 21. Step-by-step allocation using VAM. Step 1. Find row and column penalties. Example. Row S3 min is equal to 8, next min is equal to 40, penalty is equal to 32. Step 2. Highest penalty is 32, S3. Choose cell with minimum cost in S3 8, D2. Step 3. Allocate min, 18, 8, is equal to 8 units to S3 D2. Adjust supply and demand. Step 4. Repeat penalty calculation and allocation for remaining cells. Why VAM is better? It considers cost differences, helping to avoid expensive choices early. Gives a closer to optimal starting solution. Easy tip to remember. Penalty-based smart start. Always begin where a wrong move is most costly. VAM helps managers plan efficient transport routes, saving cost and time. Next important long question is to write the mathematical formulation of transportation problem and explain it with assumptions. Mathematical formulation of transportation problem explained with assumptions and example. What is a transportation problem, TP? A transportation problem deals with moving goods from multiple sources, factories, to multiple destinations, warehouse customers, at minimum cost, while satisfying supply and demand. Mathematical formulation. Let M number of sources, factories. N number of destinations, warehouse customers. AI, supply available at source I, for I is equal to 1 to M. Bj, demand required at destination J, for J is equal to 1 to N. Sig, cost of transporting one unit from source I to destination J. Xij, number of units transported from source I to destination J. Objective function. Minimize total transportation cost. Z is equal to subject to supply constraints from each source. Demand constraints to each destination. Non-negativity. Xij greater than or equal to 0. Assumptions of transportation problem. The supply and demand are known and fixed. The cost per unit of transportation is constant. All goods are homogeneous, same kind. The goal is to minimize total cost. Transportation routes are available from each source to each destination. Simple example. D1 D2 supply. S1 4630. S2 5340. Demand 2050. Objective, send goods from S1 and S2 to D1 and D2 at minimum cost. Easy tip to remember. Send goods from where they are to where they are needed at the lowest price. This is what the transportation model helps you do mathematically and efficiently. Next important long question is 3. List and explain various methods to find initial basic feasible solution, IBFS, in TP. Initial basic feasible solution, IBFS, in transportation problem methods explained. What is IBFS? In transportation problems, the initial basic feasible solution, IBFS, is the starting solution that satisfies all supply and demand conditions without necessarily being the lowest cost. From IBFS, we move towards the optimal solution. Conditions for IBFS. For a transportation table with rows, sources, NN columns, destinations. The number of basic allocations should be exactly allocations is equal to M plus N1 / text allocations is equal to M plus N1. Methods to find IBFS. 1. Northwest corner method, NWCM. Start from top left, northwest corner of the table. Allocate as much as possible, min of supply demand. Adjust row column and move right or down. Example. If S1 is equal to 20, D1 is equal to 15, allocate 15 in cell S1 D1, update S1 is equal to 5, D1 is equal to 0, move to D2. Easy to use. Ignores cost may not be cost effective. 2. Least cost method, LCM, or matrix minimum method. Choose the cell with the least cost. Allocate maximum possible. Cross out satisfied row column. Repeat with next lowest cost. Better than NWCM. Slightly more time consuming. 3. Row minimum method. Go row by row. In each row, find lowest cost cell and allocate as much as possible. 4. Column minimum method. Go column by column. In each column, allocate to least cost cell in that column. 5. Vogel's approximation method. 1. Calculate penalty is equal to difference between lowest and second lowest costs in each row column. Choose the highest penalty row column. Allocate to least cost cell in that row column. Most accurate and near optimal IBFS. Needs more calculation. Quick recap tip. NWCM fast. LCM low cost. WAM very accurate method. Always try WAM first, it usually gives a solution very close to the final answer. These methods help in starting the journey to minimize transportation costs effectively. Next important long question is 4. Solve the assignment problem using Hungarian method, problem-based question expected. Solve assignment problem using Hungarian method step by step with example. Assignment problem overview. Assignment problem means assigning n jobs to n persons or machines in such a way that cost is minimum or profit is maximum. Problem. Assign 4 jobs, J1 to J4, to 4 workers, W1 to W4, with the minimum cost using the cost matrix. J1 J to J3 J4. W1 9 to 7 8. W2 6 4 3 7. W3 5 8 1 8. W4 7 6 9 4. Step-by-step solution using Hungarian method. Step 1. Row reduction. Subtract the smallest number in each row from all elements in that row. Min of each row, W1 is equal to 2, W2 is equal to 3, W3 is equal to 1, W4 is equal to 4. Step 2. Column reduction. Now, subtract the minimum of each column from all elements in that column. Column mins J1 is equal to 3, J2 is equal to 0, J3 is equal to 0, J4 is equal to 0. J1 J2 J3 J4. W1 4056. W2 0104. W3 1707. W4 0250. Step 3. Assignment. Now assign jobs where there is only one zero in row column. 1. Assign W1 J2. 2. Assign W2 J1. 3. Assign W3 J3. 4. Assign W4 J4. Perfect assignment found with no conflicts. Final assignment and cost. W1 J2 cost is equal to 2. W2 J1 cost is equal to 6. W3 J3 cost is equal to 1. W4 J4 cost is equal to 4. Total cost is equal to 2 plus 6 plus 1 plus 4 is equal to 13 rupees. Quick recap tip. Row reduce, column reduce, assign zeros. Hungarian method ensures minimum total cost. Easy, clean, and quick. Use this for any n times n assignment problem. Next important long question is 5. Explain the managerial applications of TP, AP, and TSP with examples. 1. Transportation problem, TP. What it is? Transportation problem is used to find the most cost-effective way to transport goods from different sources, like factories, to different destinations, like warehouse. Managerial application. Managers in logistics, supply chain, and operations use TP to minimize transportation cost while meeting supply and demand. Example. A company has 3 factories in Hyderabad, Bengaluru, and Chennai, and 4 warehouses in Delhi, Mumbai, Kolkata, and Pune. TP helps the manager decide how many units to send from each factory to each warehouse so that transport cost is minimum. 2. Assignment problem, AP. What it is? Assignment problem helps to assign tasks, jobs, or people in the most efficient and cost-effective way, where each task person is assigned only once. Managerial application. Used by HR managers or production heads to assign employees to tasks, machines to jobs, or projects to teams for better productivity and lower costs. Example. If there are 4 delivery boys and 4 delivery routes, AP helps assign each delivery boy to a route so that total travel time is minimum or returns are maximum. 3. Traveling salesman problem, TSP. What it is? TSP finds the shortest path for a salesman to visit a set of cities once and return to the starting point. Managerial application. Used by delivery services, sales managers, or courier companies to reduce travel distance and time and save fuel cost. Example. A sales executive in Hyderabad must visit customers in 5 different cities. TSP helps him find the shortest round trip so he can save time, travel less, and visit more clients in a day. Conclusion. Model used for main benefit. TP goods transportation lower transport cost. AP job task assignment maximum efficiency. TSP route planning time and fuel saving. These models help managers in planning, saving costs, and improving operations in real-life business situations. Next important long question is: 6. A company has 5 jobs V, W, X, Y and Z and 5 machines A, B, C, D and E. The given matrix shows the return in rupees of assigning a job to a machine. Assign the jobs to machines so as to maximize the total returns. Machines jobs. A, B, C, D, E. V 5, 11, 10, 12, 4. W 2, 4, 6, 3, 5. X 3, 12, 5, 14, 6. Y 6, 14, 4, 11, 7. Z 7, 9, 8, 12, 5. Solve the assignment problem using Hungarian method to maximize returns. Step 1. Convert maximization to minimization. Hungarian method works for minimization, but here we need to maximize returns. So, subtract each element from the maximum value in the matrix, which is 14. A, B, C, D, E. V 9, 3, 4 to 10. W 12, 10, 8, 11, 9. X 11 to 9, 0, 8. Y 8, 0, 10, 3, 7. Z 7, 5, 6 to 9. Step 2. Row reduction. Subtract the smallest value in each row from all elements of that row. A, B, C, D, E. V 7, 1 to 0, 8. W 4 to 0, 3, 1. X 11 to 9, 0, 8. Y 8, 0, 10, 3, 7. Z 5, 3, 4, 0, 7. Step 3. Column reduction. Subtract the smallest value in each column from all elements of that column. A, B, C, D, E. V 2, 1 to 0, 1. W minus 1 to 0, 3 minus 6. X 6 to 9, 0, 1. Y 3, 0, 10, 3, 0. Z 0, 3, 4, 0, 0. Now adjust any negative values to 0. We can't have negative costs in the Hungarian matrix. A, B, C, D, E. V 2, 1 to 0, 1. W 0 to 0, 3, 0. X 6 to 9, 0, 1. Y 3, 0, 10, 3, 0. Z 0, 3, 4, 0, 0. Step 4. Assignment. Now assign zeros without repeating row or column. VD. WA. X not yet, D is taken. YB. ZE. Try again by crossing out covered zeros and adjusting until you get optimal assignment. Final assignment based on original returns. Job assigned machine return rupees VD12 WA2 XC5 YB14 ZE5. Total return is equal to 12 plus 2 plus 5 plus 14 plus 5 is equal to 38 rupees. Conclusion. By using the Hungarian method, we assigned jobs to machines in a way that gives the maximum return of 38 rupees. This method is very useful in real life for maximizing profit or minimizing cost while assigning tasks efficiently.